Thank you very much. So in this session, I will be walking you through this real-time extended reality multimedia, a software solution from Nokia, which allows you to use 360 video and spatial audio in industrial and enterprise applications. And this is what is enabling these remote controlled operations. That is the bigger topic here today. And we were supposed to have one of our customers, Turku University of Applied Sciences, also here today to explain more about one of the use cases. But unfortunately, the speaker got sick, so he's not able to join today. So the focus will be today on this Nokia solution. And then at the end, I will give you a brief introduction into that customer use case as well. But that means that today's session might be a little shorter than was planned, but we will have more room for your questions then. So let's get started. So real-time extended reality multimedia. Many of you might know Nokia nowadays from the networks that we are doing, mainly the fixed networks and the mobile networks. Some of you may remember Nokia from the mobile phones era some time ago, but something that has been always there as part of Nokia all through these years are the multimedia technologies. So the video and audio codecs, the standardization work that we do, and the licensing business that's built around that. So what we want to do with this multimedia technologies is to actually give our customers the solutions beyond the connectivity. So once they have the Nokia's private 5G network or the consumers that have the connectivity, there's something that they want to do with the network. So this RxRM solution is an application for the industrial metaverse that enables you to use the 360 video with very high quality and low latency. Sorry, a small glitch there. So I was about to say that this RxRM is a solution for the industries, and the common problem that all the industries have, even though they might have their private network, and they want to use more and more video applications, may that be remotely controlling their vehicles or in an underground mine or in the maritime port. They want to use video, but that requires high uplink capacity. And that's when the problems start to come, that the network just can't upload all the video that the customers want to use. So our solution here is built for optimizing that video traffic in the networks. So in short, we're only sending what needs to be sent and providing that with high quality and low latency. So in today's agenda, I will walk you through the RxRM, what it is about, and then give you some use case examples where it is currently being used. And then we have this Turku University of Applied Sciences case study. So how RxRM is used to enable robotic teleoperation. So as a summary of the RxRM technology, we are a software solution, operate with different kinds of cameras or microphones, different kinds of server hardware and viewing devices. But basically how the multimedia flow is that you have a camera, a 360 camera typically, that is filming with high resolution, and that is producing very high bit rates that we would need to send to the uplink of the network. But sending 100 megabits per second is not practically possible in many environments. So what we do is that we have this RxRM media processor on the edge. This is the software component that runs on the edge computer. And then we do the processing so that we only need to send 5 megabits to the uplink. We can go even lower or higher, depending on the customer's network environment. But 5 megabits per second is the typical sweet spot for many applications. And just to highlight that we are not compressing the video, we are optimizing it by sending only what needs to be sent. On the next slide, I will focus on that part a little bit more. But there can be then multiple viewers connecting to the same RxRM system, and they get the individual view. So if you have 2 viewers, one using the VR glasses and another one using the web viewer just on the web browser, they can view their own streams from the same 360 camera and getting the high quality, low latency stream direct to them. So it's completely end-to-end solution with the independent views. Then we also have the open API to the solution, which allows, for example, the case study that we will talk about later today. So the streams can also be exported into external systems. So the user is not logged into our UI, but they can just take the streams after our optimization processing. And if they want to do some video analytics or audio analytics, that's possible. And then they could also bring the results back and draw them as overlays on top of the video. So how does this compare to the traditional video setups then? In many cases, this video is used by enterprises, but it's often just normal CCTV cameras that are cable connected and just pointing at one direction. Or in some cases, they might have a mechanical PTZ camera that can change the view, but it's still only one direction that you can get from the camera at one time. So with the RxRM, you can create truly mobile camera systems, which can operate in the 4G or 5G networks instead of these cabled cameras that are only in fixed locations. We can also create the fully immersive view from the camera location. So you can feel like you are there where the camera is positioned instead of having just one view locked wherever the camera is pointing at. And that immersive feeling can be created with the head-mounted displays or other devices that can provide the 360 view. It can also have cost-saving aspects, as you don't have to have multiple cameras in one location or pointing at different directions, but you can replace it with just one camera. And you can also have multiple users looking at the same streams. So there is this flexibility in the system. The RxRM also doesn't have any limitations on the resolution or video quality. So we can support the cameras that the customer needs to have, whatever quality that is, and we just process that, optimize the bit rates, and then send it to the viewer. RxRM is optimized for wireless. So one thing that separates Nokia from the competition in this area is that there are camera companies that can make the devices, they can do some video processing, and then there are network companies who can build the networks. But Nokia has experience in both of these worlds. So we know how to process the multimedia and we know how to send it over the networks so that we can optimize the latency and quality. So that is the unique aspect that Nokia has to bring into the metaverse. In addition, the RxRM is flexible, so you can start by building your system with just one camera, one server, and then add more cameras and users as you go, and your use cases expand. So it is very, very flexible way to start building your metaverse video applications. So how do we do this optimization of the high bitrate 360 video? In the beginning, we have the 8K resolution full sphere of the 360 video, and that is sent to the RxRM media processor, which selects the section of the 360 video that the viewer is looking at currently, and only that part is sent to the viewer. This might sound quite simple, actually, for some of you, but to do this, we really need to establish a peer-to-peer connection between the viewer and the server. And over complicated networks, for example, a private network in a mining site that is connected to the internet via NATs and firewalls, it's not that simple to establish that connection where you can do this. So we have built the solution so that we can establish the peer-to-peer connection, and then that enables really the low latency that we can provide. In typical or competitor solutions, the processing is done on the cloud. So you need to send the full 360 video to the cloud, consuming that very high bitrate uplink, and then processing it there. And from the cloud, you send it to the viewer. And this usually leads to several seconds, if not more, of latency. And that rules out many of the use cases when you really want to have a real-time view. So with RxRM, you can get below 1 second latency. Depending on the optimization, we usually get around 500 milliseconds to 900 milliseconds of latency. So then a few examples of the use cases where RxRM is currently being used. So as an example, the industrial automation is one case. So instead of just having the CCTV cameras on an industrial site, you can add more of these 360 cameras, which can enable you to use IoT solutions and the AI video analytics or audio analytics. So as an example, if you have a paper mill where you want to monitor the condition of the machinery, you could have these sensors around the machine and then always have the best situational awareness of what's happening around the machine. What does it look like and what does it sound like? And those can indicate the possible fault states that the machine is running into. And then you could automate that using AI and prevent or do this preventive maintenance. Remote operations is the main topic of today's use case. So in growing numbers, the mining sites and the harbors around the world are being remotely operated. So the mining vehicles, they are autonomous, either fully or in part. But in some cases, in certain situations, you need to have the human on site. But the human doesn't necessarily need to be physically on site, but they can also be there virtually if they have this good understanding of what's going on by using a 360 video and spatial audio. So in practice, we could equip mining vehicles with the RxRM system. So there's a camera and a server processing the video and then sending it to the viewers whenever the vehicle is in a situation that the autonomous system can't handle. So then the human user just opens the stream and then tells the machine where to go or what to do. Surveillance systems can be implemented using 360 cameras. So again, instead of just having cabled cameras that point in certain directions, you can use these wireless cameras in more use cases when you have the 360 view available. So you can put the system on a drone or have it moving with a person who wants to show a certain location on the site. Then two more use cases that I would highlight are remote training. So the old way of training people is to show them pictures and text on the PowerPoint format, but what truly gives the people a good learning experience is to actually experience it. But in many cases, like mines or other industrial sites, it's dangerous to go there. So we want to minimize the amount that people spend on site in the dangerous locations. But when you have experienced something in VR or in the metaverse, you learn much faster than by just looking at the photos or text examples in the training sessions. So what we will enable is this faster and more efficient learning by using 360 video training with 360 video. And another similar use case is the remote expert assistance. So in industrial sites, there are certain maintenance tasks or repair tasks that the technicians need to do. And in many cases, they need the help of an external expert, the one world-class expert who knows how to fix that paper machine or fix that other industrial equipment. So the use case is such that the technician who is on site takes the 360 camera to the machine and then sends the 360 video and spatial audio to the remote expert who can view the stream from anywhere in the world. They don't need to travel on site, but they can help immediately when the help is needed. And again, compared to just filming it with your mobile phone, the 360 video and spatial audio can provide the fully immersive experience. So just as you were there, you can hear the direction of the sound. Where is that bearing making sound that is indicating the fault state or whatever that is? Those experts, they have learned to see and hear the problems, and then they can utilize that expertise into Metaverse. Do we have any questions at this stage, or should we move on to the use case example with Turku University of Applied Sciences?
There's no questions currently within the chat, but if anyone does have a question, please do raise your hand and we can take you off mute to ask. Okay, I think we should be able to continue then.
All right, so I'll just switch document. So are you able to see this now?
Yes, the case study
okay.
slide is there, yeah.
Yes, perfect. So we've been working on with Turku University of Applied Sciences for about 6 months now. And in this time frame, they built a solution on top of RxRM that is enabling this teleoperation solution. And what they are using is the open API of RxRM that we mentioned. So they are just using the processing capability from RxRM, but they built their own Unity application on top of that so that the viewer can see the 360 video from a remote location, and then they also have the capability to remotely control the robot that has the 360 camera on. So Mika Luimula has been our main contact there. He's leading the Futuristic Interactive Technologies research group at the Turku University of Applied Sciences. It's a large organization. They have many projects ongoing, and this is one of them. And the larger topic that they are working on is the maritime metaverse. So how to make it more efficient to build ships and to use them So as an example, one research that they are now doing is using these point clouds on top of 360 video to improve the ship energy efficiency. The platform that they have now built as the first step was built on top of this Omron robot. So you can see the 360 camera mounted on top of the robot, and then that was streamed wirelessly from the robot to the remote viewer who had the head-mounted display on, and the user could then control this robot remotely. There was also another 360 camera in the same space with this robot, so the viewer could easily swap between the camera views so that they can get an overall view of the space or then the view from the on board on the robot. And this is being used as an example for I think it was 2 or 3 days consecutively. So the overall data that the system was producing from the 360 camera was 1.8 terabytes, but what was only sent was 82 gigabytes to the uplink. So that was the difference that the RxRM solution was able to bring. So instead of sending this huge amount of data, we only sent a moderate amount, and all that with high quality and low latency. The example use case was conducted during this Metaverse event in Finland, which happened in Tampere, about 200 kilometers from the university where they had the robot. So they were streaming from one city to another, and also the control commands were then sent from the event site back to the robot, and all working seamlessly. So this was the use case. Of course, at this stage, it was still a demonstration, but the system has been built so that this could be now used directly on a maritime vessels or other vehicles that want to be remotely controlled. So this is truly enabling the remote operations of these vehicles. So as I was saying in the beginning, unfortunately, our main speaker for this use case got sick today. So I was only showing you the high-level introduction to the use case, but this is a public document that we produced. So this will be available on the Nokia site. So you can download this and then send us any questions later if you have any, or if there's now any questions in the Q&A, I'll be happy to answer those.
Just checking the chat. We still don't have any questions within the chat, but if anyone does have any questions, please do raise your hand or pop them in the chat now. Or if there's any, if you wanted to know any more information about what we've just been talking about, again, please pop that in the chat or raise your hand. If you raise your hand, those of you, everyone's probably familiar with Teams, but those of you that may not be, at the top of your screen, you should have the raise hand button. If you press that, then I'll be able to get you off of mute and allow you to use your microphone.
Also, would be interesting to hear if anyone has any thoughts or ideas on the use of 360 video in the Metaverse context.
Doesn't look like we've got any questions. Just checking the chat again. There's nothing coming there. No one's raised their hand yet. We've had one comment in the chat that says intercity taxi operation. I'm guessing this is a user case that this could be used. I mean, that could be quite a good one.
Yeah, I'm assuming that this would be some kind of a robotic taxi that has the cameras on board, and then those could be streamed to a remote operator. I suppose the world is moving towards autonomous vehicles in many cases, but as the world is not perfect yet, it's not ready. So the autonomous systems, they can operate maybe 90-95% or even more of the time fully autonomously. But then when there are these situations where they get stuck or they don't know what to do, that's when the human interaction is needed, and the good situational awareness that they can get using 360 video is crucial. So instead of having just fixed cameras around the vehicle that give you each direction separately, you can just put on the HMD and look around, and you will understand what is the situation that the vehicle is in, and then you can tell the vehicle that, okay, now take this route or take that route. Just be careful of that person over there, as an example. So yeah, good use case.
Is there anyone else that has any questions for Ismo or anything they wanted to discuss around this topic? Please feel free to raise your hand or pop it into the chat. I think Ismo. By the looks of it, I think that.
Yeah. If we have a minute, I could give you a quick online demo of the system.
Oh, yep.
That couple of minutes.
Yeah, please do. That would be amazing. Yeah, perfect. Yeah, we've still got time in this session, so yeah, having a demo would be brilliant.
Just a moment. So actually, this is a truly live demo now. Where I am today is the Kallio test mine in northern Finland, and we have mounted the system on top of this vehicle that's operating in the area. Just half an hour ago or an hour ago, I was still 400 meters underground where we were using this same system on this vehicle. And what Kallio test mine is doing, it is providing environment for the mining OEMs for R&D purposes. So the mining environment can be used for testing the mining vehicles that the companies are developing. And what RxRM can provide is this remote viewing of the R&D tests, so that when they drive in the mining tunnels, not all people need to go down there, but they can view it from the ground level or even from different cities where they have their R&D centers. So that's one example of the RxRM use in this site. There's also mining companies that come to the site to get training, for like safety training for operating in different kinds of mining environments. So in that case, Kallio could be using the system for giving first the virtual tour of the environment that they're going to be in. And only after that, they take the people down underground so that the people already get the first experience virtually. And then the actual training will be more safe and more efficient when the people have that first learning experience already. And here I can also enable the bitrate meter. So at the moment, this is consuming about 5 megabits per second. I'm not sure what it looks like through Teams, which might be dropping some frames or reducing the quality. So that's something I can't know for sure at this moment. But overall, this sent it's good quality video, as we can do that viewport selection on the edge and only send what needs to be sent. Hopefully this opens up a little bit more about what the RxRM is about.
That was a great demo. Thank you very much for sharing that with us all today.
Thank you.